Hello viewers, I am Dr. Mala Das Sharma. Welcome you to my channel Chemphilic. Let's start episode number 57 of Teaching Chemistry through Riddle. Here is our riddle number 57, which is an organic chemistry problem related to identification of few compounds, and you have to mention the reactions involved as well as the mechanism of the reaction. So let's start riddle number 57. X is the first member of an aliphatic homologous series. It can be transformed to compound Y with very unpleasant smell through an well-known reaction. This conversion reaction is considered as the test for the functional group present in X. On treatment with dilute mineral acid, Y can be transformed to X. On prolonged heating, Y is converted to its isomer Z. The next higher member of X can be prepared from Z. So, this is our riddle number 57. Now, we'll discuss this problem on the basis of the following points. First one, identification of the compound X. Second point, description of the well-known reaction by which X can be converted to Y and identification of Y. Third point, generation of X from Y. Fourth point, identification of Z. And fifth point, the next higher member of X and its preparation from Z. Now let's see. Compound X may be methylamine, or we assume compound X is methylamine. Now let's justify. If it is methylamine, then the reaction involved in the conversion of X to Y, and Y is an unpleasant smelling compound as given in the riddle. So, this conversion of X to Y may be carbylamine reaction, whereby isocyanides are formed which has very unpleasant smell. So, what is carbylamine reaction? Primary amine, not secondary or tertiary, when treated with chloroform in presence of alkali, then alkyl isocyanide, alkyl or aryl isocyanide or carbylamine is formed. If you take methylamine, when it is treated with chloroform in presence of alkali, then methyl isocyanide or methyl carbylamine is formed. These isocyanides are having very bad smell. So, our Y may be, that is methyl isocyanide, which is formed from X. X is this methylamine, which is formed from X through carbylamine reaction. So, Y is methyl isocyanide. And already I told, this carbylamine reaction is given by only primary amine, not by secondary or tertiary. So, this reaction can be taken as the test for primary amino group. Now, mechanism of this carbylamine reaction. What happened? In the first step, this is chloroform and alkali. Alkali take this H plus and it forms this compound, from where chloride ion is removed and this dichlorocarbene is formed. this dichlorocarbene, it has one vacant orbital. See, this carbon is tetravalent. It is attached with 2 chlorine and one orbital contains this pair of electron and another vacant orbital will be there. In the vacant orbital, it can accept pair of electrons. So, these carbenes are electrophile. Now, this primary amine, through this lone pair of electron of nitrogen, it attacks this dichlorocarbene. That means this nucleophilic atom. And then what happened? This nitrogen becomes positively charged and this carbon becomes negative. Now, to neutralize this positive charge of nitrogen, this H plus is removed. And then what happened? From here, chloride is removed, and as this chloride is removed, this negative charge will be neutralized, and then this lone pair of electron will form a double bond between nitrogen and carbon. Then what is the final result? Rn. Once again, N become positive because this lone pair is forming this double bond. So, N positive, and now it is attached with only one hydrogen because one H plus is already removed, and then carbon once again becomes negative because this lone pair forms this double bond and carbon is attached to chlorine. Again the same thing is repeated, then alkali will take this H plus, so that this positive charge is neutralized, and from here chloride is removed. When chloride is removed, this negative charge will be neutralized, but this lone pair of electron will form the triple bond now. So nitrogen once again becomes positive and carbon becomes negative. So this is alkyl isocyanide. Now, these isocyanides are hydrolyzed by dilute mineral acid to form the primary amine. Let's see. So this is methyl isocyanide. In dilute mineral acid, it forms this primary amine. Let's see the mechanism. So this is isocyanide. This carbon is negative. Now H plus, acid medium, it will come here. So, and then what will happen when H plus is coming here? This pair is neutral, this negative charge is neutralized, and then what happened? Now this bonded electron pair shifted here to neutralize the charge. So what we'll get? CH3N, then here double bond and CH. Now carbon is positive. Now OH minus from water will attack this positively charged carbon. Then what we are getting? CH3N, double bond, CH, then OH. Now it undergoes tautomerism, or tautomerism takes place. How? This lone pair will form a double bond here. This bonded electron pair shifted here, and this bonded electron pair shifted to oxygen. So hydrogen removed as H plus. That H plus attached to this nitrogen. So CH3NH, C here double bond O and H. Now hydrolysis. Here it breaks down. Now hydrogens attached here, OH attached here. So from here we will get methylamine, and from this side we will get this formic acid. So Y can be hydrolyzed to X. What is our Y? Methyl isocyanide. So on hydrolysis, it is giving the compound X, that is methylamine, and this Y is formed from this methylamine only, and through this hydrolysis once again Y has been converted to X, that is methylamine. That means methyl isocyanide is converted to methylamine by hydrolysis with dilute mineral acid. Now, on prolonged heating, Isocyanide rearranges to form cyanides. That means it undergoes isomerism, structural isomerism on prolonged heating at 250 degrees centigrade temperature. From isocyanide, it forms this cyanide, the alkyl or arid cyanides. So if we take this methyl isocyanide on prolonged heating at 250 degrees centigrade temperature, you will get methyl cyanide, and according to our riddle, this is our compound Z. Now, it's methyl cyanide on reduction by using a reducing agent, say lithium aluminium hydride, it forms the ethyl amine. I'll show you. So, this is methyl cyanide on reduction. That means here and here hydrogen will be added up. So, CH3, CH2, NH2. So, it is ethyl amine. Ethyl amine is the second member of this alkyl amine homologous series. That means it is the higher member of methyl amine. So, from this methyl cyanide, through reduction, you can form ethyl amine, which is the higher member of methyl amine. Okay. So, now coming to the last part. So, we have identified all these compounds. So, X is our methyl amine, CH3NH2. And Y is our methyl isocyanide, that is CH3NC. Z is our methyl cyanide, that is the isomer of isocyanide. And then the next higher member of X, our X is methyl amine. So next higher member is methyl amine, which we have identified. So we have come to the end of this video. Thank you.